All right, let's take a look at problem number 2. This one is a little bit different. It has some challenges to it because if you notice, we don't have a single concentration for Y that is constant, okay? But we do have concentrations for X that are constant. So what we're going to do is we're going to first determine what the order is for Y and then see if we can't work through algebraically backwards a little bit. So here's what we want to do. Okay, first, as always, we're going to write out the rate for the rate expression. Okay, rate equals k, x to the a and y to the b. It doesn't matter what you put in here. I'm just trying to be consistent with what is listed for the initial of x and the initial of y. Okay, and I'm going to do this the long algebraic version. Okay, so I'm going to pick something that is constant for x. So I'm going to pick these two experiments, so experiment number 2 and experiment number 3, and I see this doubling of these two. Now, whenever you see the doubling of these two, I tend to like to put the larger one on top because it just makes the math a little bit simpler. You can do it the other way. It works out the same. All right, so here is my expression. Okay, my expression is, just ignore these here. Okay, is experiment number 3. My rate was 2.8 e to the negative third. And that's going to, my x is 0.40, my y is 0.40, and then here is experiment number 2, 1.4, and this is 0.40 and 0.20. When I look at this, I can see that here is my rates. My rate is doubling, x is staying constant, and I see that y is going from 0.2 to 0.4, so y is doubling as well. So just like I did the first time, okay, the y doubles, x stays constant, the rate doubles, okay, therefore this is in regards to y, this is going to be first order. Now, because I do not have y staying constant, I'm going to have to do some more algebra, okay? So what I'm going to do is this, is I'm going to pick some numbers here. It doesn't matter as much. I just need to make sure that I pick two things that are different for the x. I can't hold y constant, okay? But I am just going to plug in values, but I do want to find something that doubles with x, okay? So I've got really only one option. I can go from 0.20 to 0.40, or I can do this one to this one. Now, I'm going to choose something where I can clearly kind of see that it's doubling, so I'm going to pick these two right here. So I'm picking the first two. So here's what I have. I'm comparing experiment 1 and 2. All right, I'm going to move this up. So here is my rate. Here is the value for x, and here's the value for y. Okay, and then here's my rate for experiment 1, my x, and my y. Now I have to add, I'm going to put these into the rate expression on top of each other. Okay, so what I have here is this. Here's my rate of experiment 2. Okay, all of this here is experiment 2. And this down here is experiment 1. Okay, my rate equals K2 times K.40 to the A. And this is our y. Okay, our y in the first part, we already determined this was first order. So even though I cannot cross these out because they are not the same concentration, because I already have the order for this, I can work this out algebraically. Okay? So I'm going to have to do a little bit more work on this, but I will be able to get the order of this because I know the order of the first one. So we don't have to have both A and B constant to be able to figure out this problem. As long as one of them is, we should be okay. So here's some of the worked out math that we see here. Okay, what I did here is I took this and I wrote it out long version so you can see what it looks like. Okay, our k's do divide out. All right, and here's our I've changed this format. Okay, so that 0.40 divided by 0.20, here is our order, which we don't know yet, times okay our y to the first order. All right, and when we condense this down, we get 2. And we get 2 to the a times 2. Simplified, 1 equals a, or 2 to the a, and A is going to be 0 because that's the only thing we can put in there where 1, 2 will equal 2 to the A. Okay, so this is actually a zero order reaction, okay, which is good news for our rate law expression. Okay, here's our rate law expression. Here we'll go first up to the top. We're going to plug these in here. Now we just said it was y to the first, and this is a to the naught or 0. When we do that, the x actually goes away, and this is our rate expression. Okay, because x does not affect the rate, it actually falls out of our equation. So our rate equals k times the concentration of y to the first power. All right, now we just need to pick, we can pick any one of these experiments, okay, 1, 2, 3, or 4, plug in our value, and we get our value for k. And our units here is 1 over s. Okay? So that's a way that even though we don't have two things that are doubling or two things that are held constant, we can still, if we can figure out the order of one, we can algebraically figure out the order of the other.